Welcome back, everybody, for another deep dive. You know that feeling when you lose weight, but it's like your body is fighting you every step of the way?
Ugh, tell me about it.
Well, today, we're diving into the world of fat cells to explore this new scientific discovery about their memory. It might explain why that happens.
Yeah, this is really fascinating stuff. We're going way beyond just simple willpower and calories. This is about how our biology, plays a role in all of this.
And our source for this deep dive is a 2024 study from Nature that suggests that fat cells, even after you've lost weight, still remember you being heavier.
Yeah, and it could really be a game changer, this research, I think,
Right.
because it suggests that our bodies might be working against us even, after we've done the work to lose the weight.
The study looked at fat cells from people with obesity and compared those to people who had never been obese. They even looked at changes after weight loss surgery. But what's really interesting is that even after people lost a significant amount of weight, the ones who had previously lived with obesity, their fat cells, still carried this distinct memory at the genetic level.
It's like your fat cells have a history, you know, and that history seems to influence how they behave even after you've lost the weight.
So what does this memory actually mean like for you? Well, the research indicates that in the fat cells of people who had lost weight, certain genes related to inflammation and fibrosis were more active. But at the same time, the genes responsible for healthy fat cell function were dialed down.
It's not really the combo you want, right? I mean, not only are the cells potentially like primed for inflammation, but their ability to function the right way is impaired too.
It's like a double whammy. It's so much harder to keep the weight off. What's really fascinating here is that the memory itself isn't like your DNA sequence changing. It's about something called the epigenome. Think of it as like a layer of chemical tags on top of your DNA, and they control which genes are turned on or off.
Yeah, and experiences like periods of obesity or even times of famine can leave like a lasting mark on your cells in the form of these epigenetic changes.
To test this further, researchers also experimented with mice. They found that mice who were obese and then lost weight still had these epigenetic changes in their fat cells.
And those changes had real consequences. Their fat cells were way more efficient at absorbing sugar and fat compared to mice who had never been obese. So it's almost like their bodies were preparing for another, like, potential period of weight gain.
Oh, wow. Yeah. So even after you lose weight, your body could be working against you by holding on to those calories more readily. This research suggests that this struggle to keep weight off isn't just about willpower. It could actually be influenced by, biological factors we're only beginning to understand.
Totally. It's not just about what you eat, it's about how your body responds to what you eat based on, your history with weight.
And the scientists have a theory about why this is. They believe these epigenetic changes that kind of linger are a survival mechanism, from our evolutionary past. Back in the days of feast and famine, the people who could store fat more efficiently had a better chance of surviving during times of scarcity.
Yeah, it's really interesting. It shows how our biology, which was shaped by evolution, might be playing a role in these modern day health challenges.
Now, it's important to note that this study doesn't definitively prove that these epigenetic changes actually cause weight regain. But the correlation, it's pretty strong, and it raises a lot of questions about long-term weight management and what it really means to be healthy in a world where our bodies are, still adapted for a very different reality.
Yeah, it definitely adds like another layer of complexity to the conversation. The good news is, even if we can't change our evolutionary history, understanding it could help us make better choices.
One of the lead researchers, Laura Hinte, put it this way. It means you need more help, potentially. It's not your fault. And I think just that statement alone, it could be a total game changer in how we think about weight management and how we support those struggling with weight loss.
Absolutely. It's not about blame and willpower. It's about a more nuanced, like, understanding of all these factors that are at play.
Another researcher involved in the study, Hyun-Cheol Roh, he called these molecular level insights really cool. And he's not wrong. It's incredible to think that our past experiences, can leave these lasting imprints on ourselves.
It does make you wonder, what we really know about how our bodies work and how much control we really have. But, knowing more gives us a better chance at working with our bodies, not against them.
And this brings us to a really interesting question. If our bodies are wired for feast and famine, how can we actually work with our biology rather than against it? to achieve sustainable weight goals, in today's world?
That's a big question, and it's one we'll continue to explore as we dig deeper into the specifics of these epigenetic changes and what they could mean for, your health journey.
We just explored how fat cells can remember you being heavier, even after weight loss. Let's dive a little deeper into the science behind these, epigenetic changes.
Yeah, so these chemical tags, the ones we've been talking about, they aren't actually like changing your DNA sequence. It's not like they're, rewriting your genetic code or something.
So how do they work then?
Okay, so imagine these tags are like dimmer switches and they control how active a gene is. They can like turn the volume up or down. And for fat cells that have experienced obesity, the volume's like cranked way up on certain genes even after weight loss.
So that's really interesting. Which genes are stood on high alert? You mentioned inflammation and fibrosis before. Can you explain a little more about those?
Yeah, so let's start with inflammation. The study found that in people who had been obese before, genes associated with inflammation were significantly more active in their fat cells, even, after they lost weight. And you probably already know this, but chronic inflammation is linked to like so many health problems.
So even if you lose weight, your fat cells might still be in a state of heightened inflammation. That doesn't sound good.
Yeah, it really raises some important questions about long-term health. If inflammation is still elevated even after weight loss, it could be contributing to other health issues. So that's why it's important to think about strategies that go beyond just losing weight, like how do we address this underlying inflammation?
Okay, well, what about that other gene you mentioned? The one involved in fibrosis. What exactly does that mean? And how does it affect our fat cells?
Okay, so fibrosis is basically just the formation of scar tissue.
Yeah.
And when it comes to your fat cells, this scarring can mess up their normal function and contribute to metabolic problems. And yeah, the study found that genes promoting fibrosis were turned up in these memory cells too.
So, okay, not only are these fat cells more inflamed,
Hmm.
but they're becoming less efficient, more scarred, and potentially less responsive to signals from your body because of this fibrosis.
Exactly. And that just adds like another layer of complexity, right, to this whole weight management thing.
Okay, so this all sounds a little, I don't know, bleak for anyone trying to keep weight off, long term. Is there anything we can do about these changes?
Well, yeah, it's true. These changes can make maintaining weight loss really hard, but, knowledge is power. Now that we know about these mechanisms, we can start to think about how to address them. It opens up whole new avenues for research and interventions, right? That could actually make a difference.
Yeah, that's a good point. So we talked about the genes that are turned up in these, memory cells. What about the genes that are turned down? What are those responsible for?
Well, the study found that in the cells with a memory of obesity, genes that are involved in healthy fat cell function were like suppressed. These are the genes that help your fat cells do their job properly, store fat, respond to hormones, regulate your metabolism, all that stuff.
So it's even after you've lost weight, your fat cells are stuck in this fight or flight mode. They're inflamed, scarred, and not doing their job right.
Yeah.
It makes you wonder, how can anyone maintain weight loss when their own body is working against them?
I know. It's tough, right? But remember, this research isn't about blaming anyone. It's just about understanding, understanding the complexities of weight management and how our bodies actually work. And hopefully, that knowledge will help us find better solutions.
Earlier, you mentioned a study with mice that really brought this whole thing to life. Can you remind us, what they did in that study and what they found?
Yeah, so basically, the researchers wanted to see what happened if they exposed mice with this fat cell memory to a high-fat diet again. So they took mice who had been obese and then slimmed them down. But, they confirmed that even after losing weight, the mice still had those epigenetic changes in their fat cells.
And what happened when they were put on a high-fat diet?
Well, their fat cells absorbed the sugar and fat way more readily than the fat cells of mice who had never been obese, and they regained weight a lot faster.
So it's like their bodies were, primed to gain the weight back.
You could say that, yeah. Some experts think that these epigenetic changes might be a form of metabolic adaptation, a way for the body to protect itself in situations where, food is scarce.
It's crazy how our evolutionary past could be, like, influencing our health today.
Yeah.
But didn't the researchers say that this mouse study doesn't definitively prove that these epigenetic changes actually cause weight regain?
Yeah, that's true. Correlation doesn't always mean causation. More research is needed to, be totally sure if these changes are really driving weight regain or just a factor.
Okay, so there's still more to learn. But this study gives us some really valuable insight into the connections between our genes, our environment, and our experiences, especially when it comes to weight management.
Absolutely. This kind of research is like essential for moving beyond these simplistic explanations of obesity
Hmm.
and hopefully finding, better ways to manage weight and improve health.
Fat cell memory adds a whole other layer of complexity
Yeah.
to this already complicated world of weight management, right? But understanding how it works could be the key to making real progress.
I agree. And instead of getting discouraged, let's focus on what we can control. We can't change our evolutionary history, but we can make choices that support our health and well-being.
That's a great point and a perfect way to transition to our next segment. When we come back, we'll explore some of the ways this research could impact your health journey and look at some things you can do to, like, support your body in achieving a healthy weight, long term. Welcome back to the deep dive. We've been uncovering some pretty amazing things about how our bodies work, especially when it comes to weight and fat cells. This whole idea of fat cell memory, it really changes how we think about weight loss, right?
It really does. Yeah. It shows that even at like the cellular level, our bodies can hold on to the past, and that can have a real impact on, our health.
So knowing all this, what can we actually do about it? If our fat cells are like working against us even after we lose weight, how can we ever achieve a healthy weight long term?
Well, that's the million-dollar question, isn't it? We don't have all the answers yet, but I think there are a few key takeaways from this research. First, it really highlights how important it is to prevent obesity in the first place. If you can avoid those periods of like excess weight gain, you might be able to prevent these long-term epigenetic changes from happening.
That makes sense.
Yeah.
But what about those of us who have already, experienced obesity? Is there anything we can do to like address these changes in our fat cells?
It's still early days for this research, but I think it's clear that just losing weight might not be enough. We need to
Yeah.
start thinking about ways to like address this underlying cellular memory. So that might involve things like interventions that target inflammation or fibrosis.
Are there any specific interventions that look promising?
Well, there's a lot of interest right now in, exploring the impact of things like anti-inflammatory diets and certain medications, that might be helpful. And then there are lifestyle changes that could influence gene expression too, like exercise and managing stress. This whole field of epigenetics is like rapidly evolving, and I'm pretty optimistic that we'll start to see more targeted approaches in the future.
So while we don't have all the answers right now, there's hope for those of us struggling. But, what can we do in the meantime? What are some things we can do right now to work with our biology while we wait for new treatments and therapies?
Even though we can't erase our past, experiences, we can influence how our genes express themselves. And, you might be surprised to learn that things like regular exercise, managing stress, getting enough sleep, they can all actually have a positive impact on your epigenome.
That's good to hear. So it means we have more control than we think. So it's not just about what we eat, it's really about how we live our lives too, right?
Mm, exactly. It's about creating an environment that supports healthy gene expression. And even small changes can really make a difference over time.
This brings us back to the evolutionary aspect that we talked about earlier. If our bodies are wired for feast and famine, how can we overcome those deeply ingrained like survival mechanisms in today's world where food is, so readily available, it just seems like an uphill battle sometimes.
You bring up a good point. Instead of constantly trying to fight our biology, we can try to work with it. So think about reframing your relationship with food. Focus on nutrient-dense foods that are going to make you feel full and satisfied, rather than relying on those processed foods that just like hijack your reward system. And try to pay attention to your body's hunger cues and fullness cues. Don't just eat because you're bored or stressed.
So it's not about denying ourselves or feeling guilty. It's more about like making choices that, make sense for our modern lifestyle, but also work with our evolutionary history.
Yeah, exactly. It's all about finding that balance. And, it's a journey, not a destination. Every little step you take towards a healthier, it can make a big difference in the long run.
Well, we've covered a lot of ground today. We started by exploring this fascinating concept of fat cell memory and how our experiences can like leave a lasting impact on our cells. Then we talked about some of the challenges and potential solutions for, working with our biology to achieve sustainable weight goals.
We learned that even though weight loss can be really complex, understanding how our bodies actually work gives us the power to, make better choices and support our overall health. And even though there's still so much to learn about this, this research is definitely exciting. It opens up so many possibilities for the future of weight management.
Well, thank you for joining us on this deep dive into the world of fat cell memory. We hope you learned something new today and that you feel, empowered to take charge of your health. Keep exploring, keep learning, and keep taking care of yourselves. We'll see you next time on the deep dive.